Hello and welcome to Lesson 7-4, Proving Triangles to be Similar. Just like we had a series of theorems to prove two triangles to be congruent, we also have similar kinds of theorems to prove triangles to be similar. The first one is the angle-angle similarity postulate, and it states that if we know that there are two pairs of congruent corresponding angles in a pair of triangles, then the two triangles are similar. Well, this makes complete sense, and let me show you why. Before we said that two polygons were similar if all of their angles were congruent, right? Two polygons were similar if all angles were congruent. Well, in a triangle, there are only three angles, and they must add up to 180. So I know if I wanted to find this missing angle here, I know that 115 and 36 add up to 151. So if I take 80 and subtract 151, I get 29. So both of these angles are 29. But I could have known that these had to be congruent just by knowing that one, we have a triangle, and two, the other two angles are congruent, therefore the third angle is congruent. I do not need to know that the third angle is congruent. All I need to know is that I've got two congruent angles, and that is why it's called the AA tilde postulate. So this would formally read, if angle A is congruent to angle D, and angle B is congruent to angle E, then triangle ABC is similar to triangle DEF. Let's move on to the SAS similarity theorem, or SAS tilde. The side-angle sides similarity theorem states that if an angle of one of the triangles is congruent to an angle of a second triangle, and that the sides that include the two angles are proportional, then the triangles are similar. So, looking at my diagram, if I know that angle A is congruent to angle D, and that AB over DE is the same proportion as AC over DR, then that should be DF, sorry, DF, then I know that triangle ABC is similar to triangle DEF. Now let's look at an example of this. Here, I can see that angle A is congruent to angle D because they're both 32 degrees. That's awesome. Now let's look at my proportion. I want the two sides that touch that given angle. So I have 18 for side AB has to relate to 24. And then 27 for side AC has to relate to 36. I'm now going to reduce this proportion. I see that 6 goes into both the numerator and the denominator of my first fraction to get me 3 over 4. 9 goes into both numerator and denominator of my second to get me 3 over 4 again. So, AB over DE is in proportion to AC over DF. Therefore, triangle ABC is similar to triangle DEF. We have one last theorem, and that's the SSS tilde theorem, the side-side-side similarity theorem. And it states that if the corresponding sides of two triangles are proportional, then they are similar. Basically, this is how we've been thinking about similar polygons the whole time. This is what we were doing in lesson 7-3. We just have a name now to stick to it. More formally, we could say if AB is proportionate to, if AB over DE equals BC over EF, and E equals AC over DF, then the triangles are similar. You already know how to use this one. It's very easy. You simply set up an extended proportion and solve. Thank you very much. Come in and see us if you have any questions, and have a wonderful day. Thank you.